Now I connected the circuit to the analog discovery board. So I connected channel number 1, which is the yellow and black, to source number 1. And channel number 2, which is the yellow with white strip, to source number 2, which is 2.5 volt. Then we need to open a wave generator. And then we set the values for channel number 1 and channel number 2. Channel number 1 is 5 volt, and channel number 2 is 2.5 volt. So you need to type it here, 2.5 volt, and you need to enable them. So enable this one, enable this one. So now you have the voltage now. For the other voltage, or for the output voltage or V7, you need to connect it to the multimeter, or you can connect it just to the voltmeter of the analog discovery board. So you connect it, for example, to the blue and blue, or orange and orange, whatever. So the blue will be here, blue with white strip will be here, or orange will be here, and orange with white strip will be here. So I connected to the blue. So let us see what is the value. So let's go here and then go to voltmeter. So as you see here, this is the voltage across the 6.8, which is V7, 0.537 volt. Let me write it somewhere. You just write it here. Let me write it here. For example, 0.5374. So there it is. 0.5374 volt. Okay. Then after that, what you need to do is to use superposition, which means that you turn off one source and you select see the effect of the other source, and so on. So for example, if I disabled source number 1, disable it, and look at the voltage. The voltage is negative 0.9133, whatever here. Let's see. So let's calculate this value. It is 0.9133, and it is negative. Okay, so this is a voltage V7 due to source number 2. And then you do the same for the other one. So you enable this one and disable this one. Then now you have source number 1 on and source number 2 off. And now the voltage is 1.45. So let us see here. So this is the second voltage. Let's add it to this one, plus 1.4572 or 3, whatever. So what is the voltage? The voltage is 0.534. Okay. So this give us the same, almost the same answer like the previous one. Let us see what was the original value. We wrote it here. Here it is. So compare this one with this one. So when you have two sources on, it is 0.5374. And when you have one source at a time, when you add them, it will be 0.5439. Okay, so which are very close to each other. So this is what we need to do in this experiment, almost, I believe, until now. So here we turn off source number 2 or set it to 0. We turn it off, and then measure the voltage V7 due to source number 1, and then we do the same for source number 2. And then we add them, and you should get the same or similar result as the one before when both sources are on. Then what we need to do next is to find the resistance R7. To find R7, you need to turn off both sources and connect these two wires to the multimeter and set it to ohm to measure the resistance. Okay, so as you see here, we have this short circuit here, and we have another short circuit here. So we don't have sources here. We turn off the source and the source, short circuit and short circuit, and then measure the resistance. When I measured the resistance, it was, I believe it was around 4.28 or something like this, kilo ohm. Okay, So this is the R7. Then at the end, the circuit will look like this. How? Why it look like this? Because we don't have this 4.28 in reality in the analog parts kit. Okay, so we need to make it up. So as you see here, R7 equal RAB. You need to measure it. Make sure you have the right settings and use the right probes for the multimeter. Of course, you have to set it to ohm and use the right probes. The value for R7 exactly, it's supposed to be 4.3K. 4.3K. Okay, so now we will move to the next part, which is the maximum power transfer. We need to connect. This is a voltage here. Actually, this is the exact value of the voltage, is 0.514. This is by calculation, but in measurements it was almost 0.54 volt or 0.453 something. Okay, as I explained before. And the resistance is 4.3K. In measurement, it will be a little bit different. 4.3K does not exist. So how can we do it? How can we make the Thevenin equivalent circuit? What's Thevenin equivalent circuit? Just to remind you, it is just a voltage source in series with a resistor. So this is the resistor and a voltage source. Okay. The resistance here is 4.3K and the voltage is 0.514. Okay. This one is very easy to do because all what you have to do is just connect it to the wave generator, to yellow and black, or yellow with white strip and black, channel 1 and channel 2, and set the value to 0.514, or you can set it to the measured value, 0.537 volt. It's okay. But how to make the 4.3K? You can connect two resistors in parallel or series, whatever, or more, of course, to make this 4.3K. Okay, you can do it, for example, using 4.7 and 47K. So two resistors in parallel will give you a resistor that is very similar to this. Or you can just add 2.2 kilo ohm in series. Of course, if you have 2.2 and 2.2 will be 4.4 kilo ohm. Okay, if you have 2.2 and 2.2 in series, the total will be 4.4, which is close to 4.3. What about 4.4, 4.7, and 47 kilo ohm? Let us calculate it. In parallel will be 47 times 4.7. You divide it by 447 plus 4.7. It is equal to 4.2727, which is closer to 4.3. Okay, so we will use this. We will use this one here. We'll use this one. Why? Because it is closer. Okay, that's why in the circuit here I have 4.7 and 47K in parallel, and this is what I have in the circuit here. Two resistors. You don't see the colors, I know, but at least you see that we have two resistors in parallel, and you connect one side to the source and one side to the load. So this will be, if you have a voltage source here, then this will be Thevenin equivalent circuit. Then what we need to do next is to connect this circuit as I did, and then connect multiple resistors here. So we need a resistor between this one here. For example, between these two nodes, this one and this one. Okay, and the resistance value is one of these resistors. So it is 1K, 1.5, 2.2, and this two in parallel. and then 6.8, 10K, and 20K. So this is what you need to do, is to connect these resistors, okay, in this position. And then measure the voltage. This is the voltage here. This is VL. This is VL, the voltage. Okay, and then calculate the power. What's the power? Is VL square divided by RL. VL square divided by RL. And then calculate the power here. And then repeat the same for the other one. So you just disconnect or change the resistor and measure the voltage and calculate PL. Okay, and then find the maximum value. What is the maximum value? You will find that the maximum value, this is the what is the value of the resistance that achieves the maximum power transfer. Find which one will be maximum here. Which one of this will be maximum? You will find that it is this one here. When R7, when RL, sorry, equal R7. This is the value that give you the maximum power transfer, and this is the maximum power transfer theory. Okay, so here the answer for the next one here. How does this resistance of maximum power transfer compare to R7? Here's the answer. Here is the answer. And I believe that this is a last slide in this experiment. See you in the next one, which is power AC power supply. Thank you very much.